All right. As we start this next video, I wanted to add some things I didn't really mention here and probably should have. So with our output, if the output is f of x times 2, um, notice that our final output is being, we're going to effectively, to graph it, we took our old y values and multiplied them all by 2. So I multiplied all y values by 2. As far as just how to graph it, here's what we're going to do. And so that stretches it vertically. Um, Remember, it was c times f of x. And here we have on the second one, f of 2 times x. And to graph it, we went through and kind of talked through that, hey, if it's at 1, now it's at 1/2. It all happened twice as quickly. But to be more explicit about it and probably really more helpful as far as how to graph it, take all of our existing x values and we're going to multiply them by 1/2. Remember on your first page of the notes, it talked about at a factor of 1 over c for the when your c value is inside with the x in the input. Multiply all x values by 1/2. So where if it was at 4, that's why we moved to 2. Where it was at, what would this be right here? That would be 1, 2, 3, 4, 5, 6. Now it's at 3. Okay. You're cutting them all in half. Same thing on the negative side, where it was at -3. Now it's at -1.5. We're multiplying all the x values by 1/2 as we graph it, which shrinks it horizontally. All right. So yeah, sorry for not being more explicit about that in the last video. And again, we talked about how where our period was at 5, now our period is at, the fundamental period is going to be equal to 2.5 because we have divided it by 2. It's everything. The period itself happened twice as quickly, so where it took 5 units to develop, now it only takes 2.5 units for that period to be repeated. All right, and we'll continue. Actually, we'll just start that next video, starting with the next problem.